So you've been given a quadratic function that looks something like this. 3x squared plus 2x plus k. And what we've got to do is this. Find the value of k for which f of x has one root. So let's just do a little sketch. X-axis, y-axis. We've got a positive quadratic, so it's going to have a shape something like that. And then we're just wondering whereabouts on the axis it is. Well, we know that it's going to go through the y-axis at k, where x is 0. If x is 0, this renders to 0, and the quadratic graph will go through the y-axis at k. So we're going to have something like that with the quadratic graph going through the y-axis somewhere up and down it. The other bit of information that we have is, or that we're trying to find, is we want to find the value of k for which f of x has one root. So in other words, we're trying to find where the graph goes through the y-axis such that the bottom, the very bottom of the quadratic graph is sitting on the x-axis, because then we'd have one root. If we were going to have two roots, then that's how the quadratic would be. It would go through the x-axis twice. If we're going to have no roots, it's going to be above. But if we're going to have one root, this quadratic graph, the bottom of it is going to be sat on the x-axis, and then you would have a value here, and this is your k, where it goes through the y-axis, such that if we got one root, the whole graph, or the bottom of the graph, is sat on the x-axis to give us the one root. But we want the value of k, the y-intercept of the graph, that sets the bottom of the graph on the x-axis. And so what we need to do to find this is something called the discriminant, which I've talked about in another video, which you can find. So I'll not go into the details of that, but I will tell you that it's b squared minus 4ac, and that's the little bit under the square root on the quadratic formula. And it's really important for this, and it's called the discriminant. Now then, what is the discriminant? Well, b in the discriminant, well, that's this number here, the coefficient of the x term. So we got 2 squared, b squared, minus 4 times, what's a? A is the 3 in front here of the x squared term. So 3 times, and what's c? Well, c is this. And in this case, it's k. So that is the discriminant. So we can tidy that up. 2 squared is 4, and then I've got minus 4 times plus 3. That's going to be minus 12k. We're multiplying by k. And so the discriminant comes down to this. Now then, if we're going to get one real root, and I have explained this in another video, so you could go back to that one if you wanted to. If we're going to get one real root where the quadratic graph is sat on the x-axis, the discriminant will equal 0. It will equal 0. And so we've got a bit of manipulation there to do algebraically. We could say that 4 equals 12k, and we could say that 4 over 12 equals k, and therefore 1/3, just simplifying, equals k. So what I've found is that this point here, where the graph goes through the y-axis, that's at 1/3. So if we're going to have a quadratic that has one real root, because it sits on the x-axis, then it's going to go through the y-axis at 1/3. That's what we found here. So we could rewrite what we have at the top there like this. We could say that therefore f of x equals 3x squared plus 2x plus 1/3 if it's going to have one real root. Now you can also see by the same token that if it was going to have no real roots, then it would be above, and therefore k would have to be more than 1/3 if it was going to have no real roots. If it was going to have two real roots, then can you see that k would have to be less than 1/3, because we'd have to have that quadratic graph go through the x-axis on 2 occasions. So k would have to be less than 1/3 for two real roots, or more than 1/3 for no real roots, but exactly 1/3 to have one real root.